Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. Today we are going to discussing about IP addressing and subnetting. These two topics we are going to discussing in network layer. First, let us see the overview of today's session. We are going to discussing about what is IP address first. And next we have to discuss about what is subnetting. And next we have to discuss about what are the different types of IP addresses are there in network layer. And next, what are the classifications of IP addresses that we have to see. And next, what are the rules for those classes in network layer. For these IP address, these all topics we have to see in today's session. First, let us see what is IP address. IP address is nothing but it is an IP means Internet Protocol Address. It is the Internet Protocol Address means where we are using exactly IP address, that is in network layer. In SI layer, this is a third layer. Already we discussed physical layer, data link. This is the third layer. Here we are going to use the IP addresses. It is a unique numerical label address. It is a unique address. It is assigned to each and every device. For each and every device, we are assigning with the unique number. That is the IP address that are connected to a computer network. That IP address is going to be connected to each device. That device is going to be connected to the computer network that uses for the Internet protocol for the communication. Why we are using this IP address? For the communication between the network and the device, we are going to use the IP address. So, it is like as a digital address, means it is a logical address that allows the devices to identify and communicate with each other. For that purpose, we are going to use the IP address. So, this IP address is a logical address, means whenever we are taking the IP address, the range of these IP address is 0 to 255 only. The range of the IP address is only it is having 0 to 255. And it can change based on the location. Sometimes it may change the IP address. Location of that particular device, it can be changed sometimes. So, it is assigned manually, either dynamically we can assign this IP address. But the range is 0 to 255 only. It is represented in decimal. So, mainly this IP address, whatever IP address we are giving, right, 0 to 255, that is in the form of decimal only. It has 4 octets. It is having 4 octets. This is 1, 2, 3, 4. It is having 4 octets, means it is indicated with the dot. Means x dot, x dot, x dot, x means these are the 4 octets we are representing with the dotted. That is the decimal form. So, it is already we said that the range is 0 to 255 only. So, the starting means here we have to represent like this, right? So, it is starting from 0 means we have to write 0 dot, 0 dot, 0 dot, 0. That is the starting one. To where we have to stop 255. 255 means 255, 255, 255, 255. This is the IP address string. Total it is having the 32 bits. So, how it is 32 bits means here it is 0.05. We can understand this, but we can understand only in the form of binary only. The machine can understand only binary form, right? That is zeros and ones only. Whenever we are writing these 4 octets, that is in the form of binary. Suppose take this example. This is the IP address. We already said whatever we are taking the IP address, the range is only 0 to 255 only. So, whatever number here we are writing, that is the range is 0 to 255 only. Here 128.11.3.31, these all 4 are indicating the range is 0 to 255 in between that only. At the same time, whatever is the these 128, 11, 3 and 31, we have to write in the binary form. Because the machine can understand only the binary language. That's why whatever 128 is there, that we have to write in this binary form. Suppose if 3 is there, how we are writing 3? Suppose 3, this is writing. So, exactly why we are writing 8 bits exactly, it is saying it is having total 32 bits. 32 bits divided to 4 means what? 8 only, right? That's why we are writing like this. So, how we have to write these 3 is 0, 0, 0, 0, 0, 0, 1, 1. Suppose if we calculate this one, 2 power 0, 2 power 1, 2 power 2 like this, the 2 power 0 means 1 plus 2 power 1 is nothing but 2. So, here is 3 only. Like this, we have to write in the binary form. This is the IP address. So, whatever we are giving IP address, that is in the range of 0 to 255 only. Why we are using IP address? It is a unique address. At the same time, we are communicating with the network. Whenever we are connecting through the internet, the device, whatever device is there, we have to give some IP address to that particular network. That is about the IP address. This IP address, next one is the subnetting. What is subnetting? Subnetting is nothing but in the computer network, this subnetting is talking about dividing a large network. whatever network is there, we have to divide that network into the smaller one. That is a subnet. It is a logical subnetwork. That is why it is called as a subnet. Means whatever network is there, we have to divide into the small network. That is nothing but subnetwork. So see this example here. This is the IP subnetting. Means internet protocol address we are giving to the subnet. Means we are dividing that IP address into the subparts. This is IP subnetting. So this is the example. Suppose here the class C is there. So it is having, means what we are saying here, the range is only 0 to 255, right? So here we are taking some network. Whatever network is there, that is 192.168.14.0. This is the network we are dividing. So means what is the range here? This is the range, that is 1 to 255. That is the range. Yes, that's why we are writing 1 to 255 here. So here all are connected to this particular network. This is only one network. And if it is divided into two subnets, how we have to divide? See, suppose this is the network. This is starting 192.168.14.0. This is the network. So if we divide it into two parts, the subnet is, the first part is divided into 255. Half means what? Near to 127, like that. So whatever is there, we have to divide it into two parts. So 0 to 126 is one part. At the same time, 128 to 254 is the another part. Like this, we have to divide our IP address, IP network into the two subparts. That is nothing but the subnetting. So we will understand how exactly this is writing, how it is coming to class C. We will see next PPTs. See here, first one, what are the different types of the IP addresses? What are the different types of the IP addresses? IP addresses are divided into four types, that are public IP, private IP, static IP and dynamic IP. What is public IP is? Public IP is mainly for the communication over the internet. Over the internet, for the communication, we are going to use the public IP, public internet protocol address. It is assigned by the internet service provider. Who is assigned this public IP address? That is assigned by the internet service provider. That is the public IP. And coming to private IP. Private IP is nothing but used within the local network. This private IP, that's why we have to use this particular IP within the local area network only. We have to use this address. Like your home, office network, that are comes under the private IP network. That can be assigned by your router. Public IP is assigned by ISP, internet service provider. It is the public, and if it is private, it is connected by the who is assigned by this, that is assigned by the router. This is the public and private IP. And coming to static IP. Static IP is talking about, it remains the constant. Static means what? This is a fixed one. IP address is fixed for that particular device. That is the static IP. So it remains constant. Often used for the servers and devices that need to be consistently accessible. Means the address is going to be fixed. Where exactly we are using these type of static IPs is, example is websites. Suppose if you want to log into some particular website, see, that is having the IP address. That is the static one. That is comes under static IP. And coming to dynamic IP. Dynamic means what? It will be changing periodically. That is nothing but dynamic, right? It is can be assigned by internet service provider or router. This can be assigned by ISP either or router. You can assign using this dynamic IP. So these dynamic IP address automatically assigned to the device. It can be automatically assigned to that particular device by DHCP, that is Dynamic Host Configuration Protocol. We are going to assigning that particular address. That is dynamic IP address. So, and that can change periodically also. At the same time, this IP address, exactly where we are using this type of dynamic address is, it is assigned to your laptop, smartphones. Whenever we are connected to your home Wi-Fi or network, we are going to use this dynamic IP. And suppose this is the one. So whatever IP address we are writing, that is 0 to 255 range only. So this address might change when device reconnects or after certain lease time. If the lease time is expired or if it is again reconnecting, that time that may change the IP address. That is the dynamic address. Periodically it will change the IP address. That is the dynamic. Static means fixed one. Private address is provided by the router. Public IP is provided by the ISP. This is about the types of the IP addresses. And next one is the classification of the IP addresses. What are the different classifications of the IP addresses? There are two types of the classifications. First one is the classical addressing class system and the second one is the classless addressing system. This is also called as CIDR. CIDR is nothing but classless interdomain routing. That is the classless addressing. These are the two types of the classifications of IP addresses. First, let us see what is classful addressing system. So, classful addressing system, classful IP addressing, how we are giving. See here, classful IP addressing, this is the IP address. It is having the information about how to reach the specific host. It is mainly talking about how we have to reach the specific host, especially outside of the LAN. For the outside of the LAN, how to reach the specific host, we have to go for the classful IP addressing. These classful IP addressing, the IP address is having the 32 bits. Means whatever IP address we are writing, means x.x.x.x we are writing that IP address is having the 32 bit, that is the unique address at the same time. So, this address space can be indicated like this 2 power 32 because total having 32 bits, we are indicating in the binary format, that's why 2 power 32. So, if we are giving into the dotted decimal notation, how we are giving? So, x.x.x.x means total is 32 bits, each one is divided into 8 bits. This is 8, this is 8, this one is 8 and this one is the 8. Total it is having the 888. So, total is 32. So, 128 we are writing like this. 11 is writing like this, 3 is writing like this, and the 31 is writing like this. Like this, we have to write the IP address. So, what exactly we have to remember when we are writing the this giving these dotted for this decimal notation? The value of any segment, whenever we are taking these bytes, right? These are the bytes, these are the byte, these are the bits. So, any segment of that particular byte in between the range is 0 to 255 only. Whatever we are taking these bytes, those are 0 to 255 range only. So, at the same time, there are no zeros preceding the value. Means we are not writing. So, if you are writing, suppose 11 is there, we are not writing like this. This is the wrong one. If you are writing 54, you have to write 54 only. We can't write like this. So, it will not accept that if we write like this before the preceding 0, if we write like this, it won't accept that IP address. 54 is only the correct one. We can't write. We did not use 0 preceding of that particular number. That is the IP address main, means whenever we are giving into the dotted decimal notation, we have to follow that particular rule. At the same time, it is this classful addressing totally is having the classes are 5 classes. Total it is having the, whenever we are giving the classes, the whatever 32 bits are there, that are we are going to divide it into the total, the range is 0 to 255, right? That range again we have to divide it into subclasses. Those are the 5 classes. Total is the range is 0 to 255 and again these one we are dividing into the subclasses. That are the class A, class B, class C, class D and class E. These are the some classes. So, first one, each of these classes, whatever classes are there, these classes, a valid range of IP address. Whenever we are indicating that particular class, the ranges should be 0 to 255 only. At the same time, class D and class E, these two classes, whenever we are talking about class D and class E, those are the reserved for the multicast, at the same time the experimental purposes. Means these two are only specifically for the multicast and experimental purpose. So, we can't use this D and E, class D and class E, because they are already allocated for the multicast and the experimental addresses. The order of the bits is the first octet determine the classes of the IP addresses. Whatever octet is there, means total how many octets are there? Total 4 octets. 1, 2, 3, 4 we are indicating with the dot symbol in between that octets. At the same time, it is having the classes is total 5 classes. So, IP4 address, this IP address is having the total 2 parts. Whenever we are writing these 4 octets, again it is having the 2 parts. These 2 parts are the network ID and host ID. So, we are writing total 4 parts, right? Whatever IP address is there, that we are dividing into the 4 parts. Again, that 4 parts is again divided into 2 parts. That is the network ID and host ID. First, let us see what is exactly we are allocating these network and host ID. See here. So, total already we said that total 5 classes. These are the 5 classes. Class A, B, C, D, E. These are the 5 classes. Already we discussed this is reserved for the multicast address, experimental address. We are using D and E. So, coming to network and host ID is there. Already if we said that the total having 5 classes. These 0 to 255 again it is having network ID and host ID. Net ID and host ID to host ID. Both are there. Means it is dividing into IPv4 address is divided into 2 parts. This address is divided into 2 parts. But how we have to divide the these two parts means, suppose if you come to class A, total is having how many bits still here? Total is having 32 bits. Total is 32. So, if it is class A, in that 32, we are allocating for network part, we are allocating 8 bits. And remaining part, whatever is there, 24 we are allocating for the host part. That is for only class A. In class A, we are allocating network ID part is the 8 bits only. At the same time, remaining 24 bits are allocated for the host part. That is in class A. And coming to class B, so in this, network ID is allocated for the 16 bits. And at the same time, host ID is allocated for the 16 bits. That is in class B. And coming to class C, whenever we are coming into the class C, network part is allocated for the 24 bits and the host ID part allocated for the 8 bits. This is class A, B, C. We are allocating like this. Whatever net ID, host ID, two parts are there, that are again we are dividing like this in the classes. Class A, class B, class C. These two are we are not talking because it is already reserved for the multicast and experimental purposes. Only we are talking about this is 8 bits, this is 16, this is 24 of the net IDs of class A, class B and class C. So, these class IP address mainly determine the bits that are used for the network ID and the host ID. For that purpose only we are going to use this IP address. So, the total number of networks and hosts possible in that particular network. How many networks are there, how many hosts are there in that particular network? For identifying that we are going to use the IP address. Each internet service provider or network administrator assigning these IP addresses. Who is assigning? Internet service provider or network administrator is assigning the IP addresses to each and every device that are connected to the each network. So, this is the allocation of the class A, class B and class C. At the same time, what are the rules for assigning the host ID and net ID? Already we said that whatever the data is there, whatever the 4 parts is there, that 4 parts again divided into 2 parts, that is the network and host part. These 2 parts, if you want to assign for host ID, what are the rules we have to follow? If you want to allocate for the assigning for the network ID, what are the rules we have to follow? Whenever host ID is there, that can be used to identify the host within the network. Host ID can be used for identifying the host. Host ID for nothing to allocate the host only within that particular network only. That host ID is allocated based on the following rules. What are the rules we have to follow for allocating the host ID? Within a network, within any network, the host ID must be unique. Whenever we are taking one ID, that is the host ID, that is unique to that particular network because it is within the network only, but that is also unique. This host ID in which all the bits are set to 0. See, all the bits are, suppose see this first one, see this, I already told some of the addresses are allocated for the multicast and experimental purpose, right? See what are the addresses are allocated, see here. So, 169.254.0.02, 169.254.0.16, this is for allocating link local addresses. This is the specific address, it is allocated automatically by the internet service provider only. So, loopback address, this is the loop functions. 127.0.0.0, this is allocated for the loopback address. This is also fixed one. And the next one 0.0.0, 0.0.8, these all are allocated. See, these range is also allocated to communicate within the current network and called DHCP addresses used when the host was time. For that purpose, we have to use this particular range. And 255.255, this one also allocated for the broadcast address. So, sent to all interface in the network. For that purpose, we are going to use these special addresses. These are the special addresses. We are not using these addresses for our own devices. This is the these all are the specific. They range of special IP addresses. These all are provided by the internet service provider only. See here in this host ID in which all bits are set to 0. Whenever all bits are set to 0, this is all bits are set to 0. So, that cannot be assigned because this host ID used to represent the network ID of the IP address. That's why we can't use this particular one when the host ID is going to set to 0. If the host ID in which all bits are set to 1, suppose if in host part all the bits are set to 1, that can be assigned for the host ID reserved as a broadcast address. So, if the 0 is there, that is used for the network ID. To represent the network ID, we are going to use. Means we already said A, B, C classes are there. A is having the 8 and 24. This is the network. This is the host address. And coming to B1, In B 16 and 16, both are 16. This is the next network and this is the host part. And coming to C, this is 24 and this is the, this one is 8. So this is the network part, this is the host part, right? So whenever we are talking about particular class, that time we are talking about only host ID. When we have to use this, how we have to allocate the host ID allocation. If it is which all the bits are set to 0, what it is going to say? We can't use that particular network, because network ID for representing the network ID, we are going to use that particular address. That's why we are not representing for that particular host ID. At the same time, if all the bits are going to be 1, if all bits are there 1, so that can be used for the broadcast address. To send the packets to all the hosts to present in the particular network, we are going to use the all ones. That's why we are not using if all zeros are there, so we can't use. If all ones are there, we can't use in the host ID part. That is about the rules of the host ID. And next one is the rules for assigning the network ID. So for assigning the network ID, see here in this, whenever we are talking about the network ID, so all the hosts on the same physical network that are assigned in the same network ID. So how we have to follow the rules for assigning the network ID? See here first. So network ID cannot start with the 127, because 127 is talking about the loopback function. Already we said 127 is talking about loopback address. That is the specific address that these all are the fixed addresses. We can't use these addresses. These all are provided by the internet service provider. We can't use these are the fixed one. So 127 we are not using. So 127 is coming in which class? Class A. So class A, B, C, that is also having the range. We will see in the next slide what is the range of that one. So it is reserved for the internet loopback functions. We are going to use the 127 address. That's why we are not using. So all the bits of network ID, if it is set to 1, that are reserved for the use and broadcast address. All the bits are 1 means what? Broadcast address we have to use. If the all bits are going to be set to 1, we have to donate for the specific host and the local network that are routed to the, that can also not to be used in this particular network ID. Means zeros also not used. All zeros are there, we can't use that one. All ones are also there, that can also not used in this particular network part. So this is about the rules of the network ID. So already we said that total having the classes, 5 classes A, B, C, D, E. The range is 0 to 255. How we have to allocate these particular classes? See here class A. Class A, the range of class A is 0 to 127. In these 0 to 255, again we are dividing the classes, right? The range of this particular class A is 0 to 127. And the class B range is 128 to 191. This is the range of class B. And coming to class C, the range is 192 to 223. That is the range of class 3. And coming to class 4, this is talking about 224 to 239. This is the range of class D. And coming to class E, the range is 242 to 55. That is the range of class E. Like this, we have to divide the classes. Here the difference is how much? Total is 16, here is 16, here is 32, here is 64, here is 128. Total bits it is having, total the range is 128, here is 64 it is having, here is 192 to 223, only 32 is having, 24 to 239, total is 16, 240 to 255, that is also 16. Like this we have to allocate these 0 to 255 range. So class A talking about 0 to 127. Previously already we said 127 used for what purpose? Loop back function we are going to use. For 0 for booting purpose we are using, for 1 for broadcast address we are going to use. All zeros, 0, 0.0.0.0 we are using for the booting purpose, means starting of the system, and all ones are there that can be used for the broadcast address. So coming to class A range is what is the class A range is 0 to 127. So the IP address belongs to class A that are assigned to the network that contains the range of the name. See here in that particular network ID, it is having the 8 bits long. It is having 8 bits long. Host ID is having 24 bits. Already we said that the network ID, host ID part, right? Network ID, host ID. So if it is the range of total 4 parts is there. So class A is talking about class A is total is only 8 bits for network ID. Remaining 24 we are allocating for the host. That is the class A. Host ID is allocated for 24 bits and the network ID is allocated for the 8 bits. And the higher order of these first octet is class A is always set to 1. So first bit here we are set to 0. At the same time, the remaining 7 bits, total each and every byte is having how many? 8 bits, right? 8 bits. So here this byte 1 is we are allocating set to 0, 1 we set to 0, means among these 8, how many are there? Remaining 7 are there. So the remaining 7 bits, the first octet are used to determine the network ID. The remaining whatever 7 is there, that can be used for what purpose? Network ID purpose. The 24, whatever remaining 24 is there, those can be used for the host network, host ID. For remaining all can be used for the determining the host purpose. We are going to use the remaining all 24 bits, that is in class A only. So the default subnet of this is, we are going to write it as 255.x.x.x, because we are only talking about this particular one. This only it is having 8 bits. This is only. That's why we are allocating for only this part 255.x.x.x, because these three are host. This one only the network part. That's why we are writing only the network part. So class A is having the total, how many total? 2 power 7 only, right? Because here is only 7 bits. That is the 2 power 7. Total is how many? Total 2 power 32. If you are talking only this particular one, network ID, that is 2 power 7, because 0 is allocated to fixed one. That is to determine the network ID. First octet always we are considering as a 0, right? That's why that one is going to be left. Total is 2 power 7. 2 power 7, 1 we are going to minus. Total is 126. Total how many bits are allocated for these class A? Total is 126. That is the network ID. So here two addresses are subtracted. That is the 0.0. That is the booting purpose. 127 is also loop back function. Already we discussed in previous slide. Loop back function we are using 127. These are the two special addresses. This is the starting of the system. That's why we are eliminating these two. There is nothing but 2 only here. So here total host address is 2424 minus 2. This is the host ID. The IP address range of these particular class A starting from 1, because 0 is going to be used for starting. That's why we are starting with 1. Only we are talking about network address. 1 to till 126. The range is still what? 0 to 127 only. But 127 used for what purpose? Loop back function. That's why we are eliminating 0 and 27. We are writing with starting with 1 and ending with 126. This is the range of the class A. And next one is the class B. How we are allocating the address for class B? Class B is having the total network. See, it is having the network ID is 16 bits and the host ID is 16 bits. Already we said total length is 32 bits. 16 is allocated for network part. 16 is allocated for the host part. So here it is network. This is the host. We allocated. So the higher order of these particular bits, whatever octet is there, in class B we are set to 1 and 0. So in class B, here in class A we set to 0, right? In class B we are setting to 1 0. So if we set to 1 0, total here how many bits are left here? So already 2 left means here is 6 are there. Here how many are there? Total 8 is there. 8 plus 4 means what? 14. 14 bits are determining the network ID. And the 16 bits of that particular host ID is determining the host. Remaining 16 is indicating what? Those are indicating the host ID. The default subnet mask of this particular class B. Class B range is what? To 128 to 128 to 191. The range of class B is 128 to 191. So here the default subnet mask is starting from. So this is these two are comes under this network part only. That's why we are writing these two. 255.255. These are x.x is the host ID. The class B total, how we have to calculate? Total is how many? Total is 14. 2 power 14 is, this is talking about the network address, and 2 power 16. This is total 2 power 16. That is nothing but total. This is how much? Total equal to 265534 is the host address. Like that we have to calculate the class B addresses. The range of these class B is starting with what? 128, right? This is starting with 128. This is the 128. And this is the 0. Next one is 0. Until where we have to stop? 191. So we have to stop with 191. 0 to 255 we have to go. That is the different classes. This is the class B. And suppose if you write in class B, suppose if you want to say, suppose the range 129.30.30 6.7 means if we talk about this particular IP address, what is the range how we have to say, what is the range we have to check, 0 to in between, whatever numbers are there, in between which range the number is there. So it is 129, highest one is 129, that is in this class. So this IP address comes under class B, like that we have to say. At any way, suppose if you write like that 3.7.176.75, if you write this also, this is also comes under class B, like that we have to identify. This is the binary notation and this is the dotted decimal notation. Means we have to understand only this language, decimal, but the machine understand only binary. That's why we are writing both. And the next one is the class C. Class C means total class C. This is the class C. Total, how many? Total 24. In that 24, 3 is going to be fixed. These 2 or 3 are going to be fixed. That is 110 is going to be fixed. Remaining how many are there? Here is 8, here is a 16, and here is how many is left? 5. Total is how many? Total is 21 bits. Those are talking about the network ID, and remaining 8 bits. Whatever 8 bits are there, these are talking about the host ID. So here 24 bits total network ID, host ID is 8 bits. In that 24 bits, again 110 is already first octet of IP address in that class C. So that's why we are removing the 3, and remaining how many are there? Total is 21, and remaining host ID 8 bits. And the default subnet of this particular class is how we have to write total till here network ID only, right? That's why we are writing 255, 255, 255 point X. That is the subnet mask. And the class total of these particular C is, the total is how many is there? Total is 21. 2 power 21, that is the 2097152 is the network address. 2 power 8, this is 2 power 8 minus 2. That is why we have to do the 250 in that range also, means 192.223 also. So 1 is assigned for the host part. That's why we are eliminating 1, means total is 254 address. And the range is, this class C is 192 is the starting one till where? 223. This is the till 223, from 0 to 255, 0 to 255. And this is, we don't know. That's why this is the host ID. That's why we are writing as a X. This is about the class C. And coming to class D. Class D and class C, already we said these are used for the reserved address. This can be used for the multicast and experimental purpose. So D is reserved for the multicasting. Mainly here we are setting all these 4, 1, 2, 3, 4, 1, 1, 1, 0 can be set to 0. These can be used for the setting to the octet, because here we set to 0, here we set to 10, here we are setting to 110. So coming to this class D, we are setting to 1110. So remaining bits can be used for the host address. So the range of class D is starting with 224. Here is 224 we are starting till where? 239. Till 239 we have to write the IP addresses 0 to 255, 0 to 255 and 0 to 255. That is the range of the class D. And coming to class E, it can be used for the experimental purposes. Experimental and research purposes, we are going to use the class E. At the same time, the range of this is starting with the 240 and ending with the what? 255. But already we said 255.255. 255.255. This can be used for what purpose? We are going to use this for the broadcast address. That's why we are not using this one. That's why till 254 only we have to write. That is the class E range. So this class does not have any subnet mask. The higher order of this particular octet is 1111, means this is set to 1111. We have to use this particular higher order in class E. These are the different classes in IP addresses. So coming to the summary, in this session we discussed what is IP address, and next we discuss what is subnetting, how we have to divide the network into subnet, that is nothing but subnetting. And next one is what are the different types of the IP addresses, and next we discuss what are the different classifications of the IP addresses, and what are the rules we have to follow to write the class A, class B, class C, class D and class E. To that we have to follow some rules, right? All rules we discussed in today's session. Thank you.